Welcome to our journey through the Sun, the star that powers our solar system and sustains life on Earth. In the vast cosmic arena, the Sun is our very own star, a fiery ball of plasma that dictates the rhythm of our world. Today, we'll explore 6 key facts about the Sun that highlight its incredible structure, energy production, and importance to our planet. Fasten your seatbelts, as we're about to embark on a thrilling voyage to the heart of our solar system. Imagine a sphere so colossal that it could hold over 1,000,000 Earths. That, my friends, is the Sun. But it's not just its size that's impressive. The Sun's structure is a marvel of cosmic engineering. At its core, temperatures soar to a mind-boggling 15 million degrees Celsius. Here, in this crucible of unimaginable heat, the very essence of the Sun is forged. Hydrogen atoms, under immense pressure, are fused together to form helium, unleashing the energy that powers the Sun. This energy then embarks on a long and arduous journey outward, first through the radiative zone, a dense plasma where photons of light are constantly absorbed and re-emitted, taking thousands of years to traverse. Finally, the energy reaches the convective zone, where it's carried upwards by giant convection currents, much like boiling water in a pot. We then reach the Sun's visible surface, the photosphere, a mere 5,500 degrees Celsius, cool by the Sun's standards. Above this lies the chromosphere, a layer visible during solar eclipses as a reddish glow, and beyond that, the corona, a halo of superheated plasma extending millions of kilometers into space, reaching temperatures exceeding 1,000,000 degrees Celsius. The Sun is a giant cosmic furnace, constantly churning and burning, its energy source a process as elegant as it is powerful nuclear fusion. Deep within the Sun's core, under unimaginable pressure and heat, hydrogen nuclei overcome their natural repulsion and collide with such force that they fuse, creating helium. This fusion process is the very engine of the Sun, the source of its light, heat, and ultimately, life itself. Every second, millions of tons of hydrogen are converted into helium within the Sun's core, releasing a torrent of energy that makes its way to the surface and out into space. This energy, carried by photons of light, travels at the speed of light, bathing our solar system in its warmth. It's a process that has been going on for billions of years and will continue for billions more, sustaining life on our planet and driving the very dynamics of our solar system. While the Sun may seem like a constant, unchanging presence in our sky, it is, in fact, a dynamic and restless star. Evidence of this can be seen in the form of sunspots, those dark, cooler blemishes that dot the Sun's surface. Don't let their seemingly innocuous appearance fool you, though. Sunspots are regions of intense magnetic activity, thousands of times stronger than Earth's magnetic field. They mark areas where the Sun's magnetic field lines are twisted and tangled, inhibiting the flow of heat from the interior and causing the surface temperature to drop, hence their darker appearance. These sunspots are not static. They wax and wane in number, following an 11-year cycle of solar activity. During periods of high activity, the Sun throws even more dramatic tantrums in the form of solar flares and coronal mass ejections, blasting out bursts of radiation and charged particles that can disrupt satellites, communication systems, and even power grids here on Earth. The Sun is more than just a celestial object in our sky. It is the very lifeblood of our planet, the engine that drives our climate, weather, and the very existence of life itself. Its energy, arriving as sunlight, warms our planet, powers our atmosphere, and fuels the process of photosynthesis, the foundation of most life on Earth. Plants, those alchemists of the natural world, capture the Sun's energy and convert it into chemical energy, stored in the bonds of sugars and other organic molecules. This energy then makes its way up the food chain, sustaining all life on our planet. But the Sun's influence goes beyond biology. It drives our weather patterns, from the gentle breezes to the raging storms, and shapes our climate over long timescales. The Sun's energy evaporates water from the oceans, driving the water cycle and distributing fresh water around the globe. It's no exaggeration to say that without the Sun, Earth would be a barren, lifeless rock. In the grand scheme of the cosmos, our Sun is a fairly average star, but that doesn't make its scale any less impressive. With a diameter of roughly 1.4 million kilometers, it dwarfs our planet, holding within its fiery embrace the equivalent of 1.3 million Earths. In fact, the Sun contains roughly 99.86% of the total mass of our solar system, a testament to its gravitational dominance. But what is this massive star made of? Like most stars, the Sun is composed primarily of hydrogen and helium, the two lightest elements in the universe. Roughly 74% of the Sun's mass is hydrogen, the fuel for its nuclear fusion reactions, while helium makes up about 24%. The remaining fraction consists of heavier elements, trace amounts of the building blocks of planets and, ultimately, life itself. Like all stars, the Sun has a finite lifespan, a cosmic narrative that began billions of years ago and will continue to unfold for billions more. Currently classified as a yellow dwarf star, the Sun is about 4.6 billion years old, roughly halfway through its main sequence lifespan. During this phase, it will continue to fuse hydrogen into helium, radiating energy and light into the cosmos. But even stars age, and eventually in about 5 billion years, the Sun will exhaust its hydrogen fuel. As this happens, it will begin to fuse helium in its core, causing it to expand dramatically, engulfing the inner planets, including Earth, in its fiery embrace. The Sun will then become a red giant, a bloated, luminous giant before eventually shedding its outer layers, leaving behind a dense, hot core known as a white dwarf. This stellar ember will slowly cool over billions of years, eventually fading into a black dwarf, a cold, dark remnant of a once mighty star. As we conclude our journey through the Sun, we are left with a profound sense of awe and appreciation for this celestial powerhouse that governs our corner of the cosmos. The Sun's powerful gravitational pull holds the solar system together, and its energy sustains nearly all life on Earth. It is a source of warmth, light, and life, a cosmic engine that has driven the evolution of our planet and the emergence of life itself. Thank you for joining us on this enlightening journey through the Sun. Stay curious and keep exploring the wonders of our universe.